Hi everyone, I'm Al. Here's my partner Haoran. We're going to present our project on Sensify, which is an application that suggests music based on your emotions. Our goal of the project aims to build a multi-label sentiment classification measures input with 5 emotion matrix, which are surprise, happiness, disgust, anger, and neutral. The model allows to take an input as either a sentence or a paragraph of words, and it returns a probability on 5 emotion matrix. The motivation of our project starts to use NLP models to assist the chatbot to detect technical or user experience issues by detecting negative sentiments from the user utterance. But due to the complexity of deploying a chatbot to demonstrate the model, we decided to build Sensify, a music recommendation app that generates playlists based on the classification result of the input.
So let's talk about dataset. So the source of our dataset combines 2 existing datasets from Hugging Face that are Go Emotions and Emotion. We removed the additional dimensions and manually labeled the missing dimensions from both datasets to fit with our goal. So Go Emotions is one of the most fine-grained and the largest dataset for emotion classification made by Google. It includes 58,000 Reddit comments and is labeled with 27 dimensions. So we removed the 22 additional dimensions from this data set. And emotion is a data set of English Twitter messages with 6 basic emotions: anger, fear, joy, love, sadness, and surprise. So this data set intended for multi-class classification task, and therefore the labels are mutually exclusive. So we removed the fear, love, and sadness dimension and manually labeled the neutral, disgust dimensions as well as the dimensions we think is missing. So here's an example of our process data set. On the left is the input, and on the right is the target. So you can see there are multiple labels at 1 for both examples. So for the base model, we are using a multi-label MLP classification model with 1 layer. The input is the average of words and vectors in a sentence, and you can think it as the average meaning of the words. The input is fed to a fully connected layer that produces scalar outputs with sigmoid activation, which is the probability of each emotion metric.
Yeah, the transformer model we use from Hugging Face is BERT for sequence classification, which is a transformer built on top by adding a classification hand, and we pre-trained with BERT-based and case. And the result, we count the correct labels made by the models as a measure for the performance. And the best validation accuracy between 2 models are 85.5% for the baseline and 92.2% from the BERT model.
So let's talk about Sensify. So we built the Spotify track recommendation endpoint to generate the playlist. And the 5 emotion metrics are mapped to different parameters of the recommendation endpoint. So happiness is mapped to happy genre and high danceability. So that's an actual endpoint of the Spotify actual parameter of the endpoint. And surprise is mapped to low popularity, so it's going to recommend music you have not heard before to surprise you. And disgust is mapped to sad genre because these 2 emotions are often associated. And anger is mapped to low valence, so low positiveness in the tune, and high energy, which usually means dark metal genre or rock genre. And neutral is mapped to neutral valence and high popularity. So here's a demo of our application. Okay, yeah, so that's the demo.
Yeah, lesson learned for us is pre-trained model is all you need, because when we start to work on the model in the first place, we spend a lot of time on debugging and trying to improve the performance, and actually there are a lot of bugs. And we switch our focus for the pre-trained models, which only require minimal effort on setup, and you can focus on pre-trained on fine-tuning the model. And that's the end of our presentation.
Yeah, thank you.